For the lab, we gathered some data, and now what we're going to do is compile the data. You can use your data, hopefully, that you got from your lab. What I'm going to do is I'm going to write down the data we had for the video, and let's just get down some numbers. So the mass of the nails before ended up being 2.26 grams. The cup by itself was, that's actually a weigh boat that we used, and that was 2.13 grams. And the mass of CuCl2 was 3.10 grams. The mass of the beaker, which was a cup we also used for the copper, was 8.58 grams. And then the mass of the filter paper and weigh boat together were 6.58 grams. And then afterwards, we measured the nail and the cup, and that was 3.39 grams. And to get the mass of the nail by itself, we take this number here and we subtract the weigh boat. So 3.39 minus 2.13, and that is 1.26. The mass of the beaker or cup and the solid. So the mass of everything together and the solid was 9.86 grams. And then the mass of the filter paper and everything afterwards was 9.50 grams. Okay. What we're going to do is transfer some of these numbers over to the other side and do some calculations here. So the mass of the iron reacted, was the mass of the nail before, which was 2.26 grams, and the mass of the nail after, which was 1.26 grams, and that has a total mass, subtracting it, is 1.00 grams. The mass of the product, which was the copper now we figured out, we're going to take the mass of the beaker plus the solid, so that was 9.86 grams, and minus 8.58 grams with just a cup. And we get the mass of copper to be 1.28 grams total. So that's the mass of copper. And then the mass of the iron chloride, FeCl2, that is 9.50 grams, which is the mass of the filter paper and weigh boat. And then we subtract just the filter paper and the weigh boat by themselves, which was 6.58 grams. And that ends up being 2.92 grams. Okay. And what we need to do now is compare these numbers. Now, in order to compare these numbers, we need to use, because iron and copper are different substances, we can't compare the two of them. It's kind of like comparing eggs and grapefruit, or comparing apples and oranges. They're much different from each other. And if I have a dozen of one and a dozen of the other, you can't really compare them. So we have to use a different unit for that, and that is called the mole. And so there's a video that's linked that you can watch that talks about the mole and what that is. But the mole is a number, and if I have 1 mole of atoms, of some atom, that is going to be 6.02 times 10 to the 23rd power of atoms. What also ends up happening is that if you have a mole of an element, we can use the periodic table to tell us about that. So let's say I have, because I can't count that many atoms, if I have 1 mole, so 1 mole of copper, and I don't know much about that, but if I look on the periodic table here, copper is right here, and it says that this is called the molar mass. And the molar mass tells me that 1 mole of copper atoms weighs 63.55 grams. So this actually tells me 63.55 grams of copper is 1 mole of copper. Similarly, if I look at the periodic table, iron, it tells me that iron is 55.85 grams. So 1 mole of iron, Fe, atoms is 55.85 grams of iron. And what we can use is we can take these numbers and we can actually do some calculations with these. So I'm going to do that right now. Similarly, the copper chloride I have, if I let's try that again. Similarly, the copper chloride, if I have 1 mole of CuCl2, in order to get the molar mass of this substance here, if I want to figure out what 1 mole of this substance was, I can take from the periodic table copper, which is 63.55, and then chlorine is right here. So that's 35.45. But we're going to multiply that by 2. So 2 times 35.45. And if you do that, you end up with 134.45 grams. Okay? And if you do the same thing for iron chloride, so 1 mole of iron chloride, Cl2, that's going to be 55.85 plus 2 times 35.45. Oops, there you go. And if you do that, you should get 126.75. So now what we're going to do is, this is CuCl2, and this is FeCl2. What we're going to do now is take these numbers and figure out, well, how many moles do we have of each substance? What we're going to do is a method called proportional analysis, and you should have some familiarity with proportions. And we know, so we know a couple things. We know 1 mole of Fe is 55.85 grams of Fe. And we also know that we have 1.00 grams of Fe used up. That was in the reaction. And if we set up a proportion, because we want to figure out how many moles is this? This is how many moles. So if we set up a ratio or a proportion and say, well, 1 mole of Fe is 55.85 grams. And I say it's proportional to, well, I have X moles of Fe, if I use X moles, and that's going to be 1 gram. Okay, because I know I have 1 gram. Well, can I figure out what X is? And if you cross multiply these numbers here, and say we take these two here, multiply them out, and divide it by this number here. So the cross products are equal to each other. 1 times 1 is equal to 55.85 times X. And then if I get X to be by itself, I divide both sides by 55.85. And that equals, so X equals 1 divided by that. And that gives me 0.0179 moles of Fe. Okay. So that's how many moles of Fe were reacted. We're going to do the same thing now for copper. I'm going to skip the copper chloride for just a minute because we have to make a slight adjustment to that. But the copper, I also know is 1 mole of copper is 63.55 grams. And we made 1.28 grams of copper. And if I go ahead and do the same technique I did up here, I know that 1 mole of Fe is equal to 63.55 grams. Well, how many moles, X moles of copper is 1.28 grams. And so I do my cross products. Okay. 1 times 1.28 equals 63.55 times X. And I'm going to divide both sides by 63.55. Okay. So 1.28. And that is so X is equal to 0.0201 moles of copper. So 0.0201 moles for that.